This is going extremely well, Levine said, rubbing his hands together. Far beyond my expectations, I must say. I couldn't be more pleased. He was standing in the hide with Thorn, Eddie, Malcolm, and the kids, looking down on the valley floor below. Everyone was sweating inside the little observation hut. The midday air was still and hot. Around them, the grassy meadow was deserted. Most of the dinosaurs had moved beneath the trees, into the cool of the shade. The exception was the herd of Apatosaurs, which had left the trees to return to the river, where they were now drinking once again. The huge animals clustered fairly tightly around the water's edge, in the same vicinity, but more spread out, were the high-crested Parasaurolophus, these somewhat smaller dinosaurs positioning themselves near the Apatosaur herd. Why exactly are you pleased? Because of what we're seeing here, Malcolm said. He glanced at his watch and wrote an entry in his notebook. We're getting the data that I hoped for. It's very exciting. Why is it exciting? The dinosaurs are drinking. What's the big deal? Drinking again, Levine corrected him. For the second time in an hour, at midday. Such fluid intake is highly suggestive of thermoregularity strategy these large creatures employ. You mean they drink a lot to stay cool? Thorn said, always impatient with jargon. Yes, clearly they do. Drink a lot. But in my view, their returning to the river may have another significance entirely.
Which is?
Come, Levine said, pointing. Look at the herds. Look how they are arranged spatteredly. We're seeing something that no one has witnessed before or ever suspected for dinosaurs. We're seeing nothing less than an interspecies symbiosis. We are? Yes, Levine said. The Apatosaurs and the Parasaurs are together. I saw them together yesterday too. I bet that they're always together. When they're out in the open plain. Undoubtedly, you're wondering why. Undoubtedly, Thorn said. The reason is that the Apatosaurs are very strong but weak-sighted, whereas the Parasaurs are small but have very sharp vision. So the two species stay together because they provide a mutual defense. Just the way zebras and baboons stay together on the African plains. Zebras have good sense of smell, and baboons have good eyesight. Together, they are more efficient against predators than either is alone. And you think this is true of the dinosaurs because... It's rather obvious, Levine said. Just look at the behavior. When the two herds were alone, each clustered tightly amongst themselves. But when they're together, the Parasaurs spread out, abandoning their former herd arrangement, to form an outer ring around the Apatosaurs, just as you see them now. They can only mean that individual paras are going to be protected by the Apatosaur herd, and vice versa. It can only be a mutual predator defense. So where are the predators? Right there, Malcolm said, pointing towards a stand of trees on the other side of the river, not far from the water. Thorn looked and saw nothing. Don't you see them? No. Keep looking. They're small lizard-like animals. Dark brown. Raptors. Thorn shrugged. He still saw nothing. Standing beside him, Levine began to eat a power bar. Preoccupied with holding the binoculars, he dropped a wrapper on the floor of the hide. Bits of paper floated to the ground below. How are those things? Arby said. Okay. A little sugary. Got any more? Levine rummaged in his pockets and gave him one. Arby broke it in half and gave half to Kelly. He began to unwrap his half, carefully folding the paper, putting it neatly in his pocket. You realize this is all highly significant, Malcolm said, for the question of extinction. Already it's obvious that the extinction of the dinosaurs is a far more complex problem than anyone has recognized. Is it? Well, consider. All extinction theories are based on the fossil record, but the fossil record doesn't show the sort of behavior we're seeing here. It doesn't record the complexity of the group interacting. Because fossils are just bones, Arby said. Right, and the bones are not behavior. When you think about it, the fossil record is like a series of photographs, frozen moments from what is really a moving, ongoing reality. Looking at the fossil record is like thumbing through the family paper album. You know that the album isn't complete. You know life happens between the pictures. But you don't have any record of what happens in between. You only have the pictures. So you study them, and study them. And pretty soon, you began to think of the album not as a series of moments, but as reality itself. And you began to explain everything in terms of the album. And you forgot underlying reality. And the tendency, Malcolm said, has been to think in terms of physical events. To assume that some external physical events cause the extinctions. A meteor hits the Earth and changes the weather. Or volcanic eruptions and changes the weather. Or a meteor causes a volcanus to erupt and change the weather. Or vegetation changes and species starve and become extinct. Or a new disease arises and species become extinct. Or a new plant arises and poisons all the dinosaurs. In every case, what is imagined is some external event. But what nobody imagines is that the animals themselves might have changed. Not in their bones, but their behavior. Yet when you look at the animals like these, and see how intriguingly their behavior is interrelated, you realize that the change in group behavior could easily lead to extinction. But why would group behavior change? Thorne said. If there wasn't some external catastrophe to force it, why should the behavior change? Actually, Malcolm said, behavior is always changing all the time. Our planet is a dynamic, active environment. Weather is changing. The land is changing. Continents drift. Ocean rise and fall. Mountains thrust up and eroded away. All the organisms on the planet are constantly adapting to those changes. The best organisms are the ones that can adapt most rapidly. That's why it's hard to see how a catastrophe that produces a large change could cause extinction, since so much change is currently at the time anyway. In that case, Thorne said, what causes extinction? Certainly not rapid change alone, Malcolm said. The fact tells us that clearly.
What facts?
After every major environmental change, a wave of extinction has usually followed. But not right away. Extinction only occurs thousands or millions of years later. Take the last glaciation in North America. The glacier descended. The climate changed several. But animals didn't die. Only after the glaciers resent, when you think things will go back to normal, did a lot of species become extinct. That's when giraffes and tigers and mammoths vanished into the continent. And that's the usual pattern. It's almost as if species were weakened by the major change, but die off later. It's a well-recognizable phenomenon. It's called the softening up the beachhead, Levine said.
And what's the explanation for it?
There is none, Malcolm said, as a paleontological mystery. But I believe that complexity theory has a lot to tell us about it, because the notion of life of the edge of chaos is true. That major change pushes animals close to the edge. It destabilizes all sorts of behavior. And when the environment goes back to normal, it's not really a return to normal. In evolutionary terms, it's another big change, and it's just too much to keep up with. I believe the new behavior in population can emerge in unexpected ways. And I think I know why the dinosaurs... What's that? Thorne was looking at the trees and saw a single dinosaur hop out into view. It was rather slender, agile in its hind legs, balanced with a stiff tail. It was 6 feet tall, green-brown with red stripes, like a tiger. That, Malcolm said, is a velociraptor. Thorne turned to Levine. That's what chased you up in a tree? It looks ugly. Efficient, Levine said. Those animals are brilliantly constructed killing machines. Arguably the most efficient predators in the history of the planet. The one that just stepped out will be the alpha animal. It leads the pack. Thorne saw other movement beneath the tree. There's more. Oh yes, Levine said. This particular pack is very large. He picked up his binoculars and peered through them. I'd like to locate their nest. I haven't been able to find it anywhere on the island. Of course they're secretive, but even so... Don't they care? Arby said. They're not even looking at him. Don't be fooled, Levine said. The Apatosaurus care very much. They may look like gigantic cows, but they're nothing of the sort. Those whiptails are 30 or 40 feet long and weigh several tons. Notice how fast they can swing them. One smack of those tails would snap an attacker's back.
So turning away is part of their defense?
Unquestionably, yes. And you can see now how long necks balance their tails. The tails of the adults were so long, they reached entirely across the river to the other side of the shore. As they swung back and forth, the Parasaurs cried out. The lead raptor turned away. Moments later, the entire pack began to slink off, following the edge of the trees, heading up into the hills. Looks like you're right. The tail scared them off. How many did you count? Levine said. I don't know. 10. No, wait. 14. Maybe more. I might have missed a few. 14. Malcolm scrambled in his notebook. You want to follow them? Levine said. Not now. We could take the Explorer. Maybe later, Malcolm said. I think we need to know where their nest is, Levine said. It's essential, Ian, if we're going to settle predator-prey relationships. Nothing is more important than that. This is a perfect opportunity to follow. Maybe later, Malcolm said. He checked his watch again. That's the 100th time you have checked your watch today, Thorne said. Getting to be lunchtime. By the way, what about Sarah? Shouldn't she be arriving soon? Yes, I imagine she'll show up any time now, Thorne said. Malcolm wiped his forehead. It's hot up here. Yes, it's hot. They listened to the buzzing of insects in the midday sun and watched the raptors retreated. You know, I'm thinking, Malcolm said, maybe we ought to go back. Go back? Levine said. Now? What about our observations? What about the other cameras we want to place and... I don't know. Maybe it'll be good to take a break. Levine stared at him in disbelief. He said nothing. Thorne and the kids looked at Malcolm silently. Well, it seems to me that if Sarah is coming all the way from Africa, we should be there to greet her. I think it's simply politeness. I didn't realize that, No, Malcolm said quickly. It's nothing like that. I just, maybe she's not even coming. Did she say she was coming? She said she'd think about it. Then she is coming. If Sarah said that, she's coming. I know her. So, what do you say? Want to go back? Certainly not, Levine said, peering through binoculars. I wouldn't dream of leaving here now. Doc, want to go back? Sure, Thorne said, wiping his forehead. It's hot. If I know Sarah, she's going to show up in this island just looking great.
The power of the ocean was immense. The surge dragged her forward, then back, and she was helpless to resist. She could not see the boat anywhere, only foaming sea on all sides. She could not see the island, only water. She fought a sense of overwhelming panic. She tried to kick against the current, but her boots were leaden. She sank down again and struggled back, gasping for air. She has to get her boots off somehow. She gulped a breath and dug her head under the water and tried to unlace the boots. Her lungs burned as she fumbled in the knobs. The ocean swept her back and forth, ceaselessly. She got one boot off, gulped air, and dug down again. Her fingers were stiffly with cold and fright as she worked on the other boot. It seems to take hours. Finally, her legs were free, light, and she dog-pedaled, catching her breath. The surge lifted her high, dropped her again. She could not see the island. She felt panic again. She turned and felt the surge lift once more. And then she saw the island. The sheer cliffs were frighteningly close. The waves boomed as they smashed against the rocks. She was no more than 50 yards offshore, being swept inexorably towards the crashing surf. On the next crest, she saw the cave, 100 yards to her right. She tried to swim towards it, but it was helpless. She had no power at all to move in this gigantic surf. She felt only the strength of the sea, sweeping her to the cliff. Panic made her heart race. She knew she would be instantly killed. She put her head down and began to swim, arm over arm, kicking as hard as she could. She had no sense of movement, only the sideways pull of the surge. She dared not look up. She kicked harder. When she raised her head for another breath, she saw she had moved a little. Not much, but a little to the north. She was a little nearer to the cave. She was encouraged, but she was terrified. She had so little strength. Her arms and legs ached with her effort. Her lungs burned. Her breath came in a short, ragged, heavy gasp. She was startled to see the cave was very close. A few more strokes and she would be swept inside it. She had thought the current might be less severe around the cave, but it wasn't. On either side of the opening, the waves crashed high, climbing the cliff walls, and then falling back. The boat was nowhere in sight. She ducked her head down again, kicked forward, using the last of her strength. She could feel her entire body weakening. She could not last much longer. She knew she was being carried towards the cliffs. In her exhaustion and pain, she realized that she was inside the cave. She had been swept into the cave. It was too dark to see the walls on either side. The current was intense, sweeping her even deeper. She gasped for breath and paddled inefficiently. Her body scraped against rock. She felt a moment of searing pain, and then she was swept farther into the depths of the cave. And suddenly, astonishingly, she was carried through and burst into sunlight and open air. She found herself in the middle of the broad muddy river, surrounded by dense green foliage. The air was hot and still. She heard the distant cries of jungle birds. Up ahead, around the bend in the river, she saw the stern of Dodgson's boat already tied up to the shore. She could not see any of the people, and she didn't want to see them. Summoning her remaining strength, she kicked towards shore and clustered at the stand of mangroves growing thickly along the water's edge. Too weak to hold on, she hooked her arm around the root and lay on her back in a gentle current, looking up at the sky, gasping for breath. She did not know how much time passed, but finally she felt strong enough to haul herself arm over arm along the mangrove roots at the water's edge, until she came to a narrow break in the foliage, leading to a patch of muddy shore beyond. As she dragged herself out of the water and up on the slippery bank, she noticed several rather large animal footprints in the mud. They were curious, three-toed footprints, with each toe ending in a large claw. She bent to examine them more closely. Then she felt the earth vibrating, trembling beneath her hands. A large shadow fell over her, and she looked up in astonishment at the leathery, pale underbelly of an enormous animal. She was too weak to react, even to raise her head. A few yards up from the shore of the river, Lewis Dodgson climbed into the custom-made Jeep Wrangler and slammed the door shut. Beside him in the passenger seat, Howard King was wringing his hands. How could you have done that to her? Done what? How could you? King said again, agitated. I mean, Jesus! What happened was an accident, Dodgson said. An accident? An accident? That's right, an accident, Dodgson said calmly. She fell overboard. I didn't see anything, Baselton said. King was shaking his head. Jesus, what if somebody comes to investigate and... What if they don't? Dodgson said, interrupting him. We were in a rough seas. She was standing at the bow. A big wave hit us, and she was washed overboard. She couldn't swim very well. We circled and looked for her, but there was no hope. A very unfortunate accident. So what are you concerned about? What I am concerned about? Yes, Howard. Exactly what the fuck are you concerned about? I saw it, for Christ's sake. No, you didn't, Dodgson said. I didn't see anything, Baselton said. I was down below the whole time. That's fine for you, Howard King said. Well, what if there's an investigation? The Jeep bounced up the dirt tracks, moving deeper into the jungle. There won't be, Dodgson said. She left Africa in a hurry, and she didn't tell anybody where she was going. How do you know? Because she told me, Howard. That's how I know. Now get the map out and stop moaning. You knew the deal when you joined me. I didn't know you were going to kill somebody, for Christ's sake. Howard, Dodgson said with a sign. Nothing's going to happen. Get the map out. How do you know? King said. Because I know what I'm doing, Dodgson said. That's why. Unlike Malcolm and Thorne, we're somewhere in this island, screwing around, doing fuck knows what in this damn jungle. Maybe we'll run into them. No, Howard, we won't. They'll never even know we're here. We're only going to be on this island for 4 hours, remember? Land at 1. Back on the boat by 5. Back at the airport by 7. Back in San Francisco by midnight. Bang. Done. Finito. And finally, after all these years, I'll have what I should have had long ago. Dinosaur embryos, Baselton said. Embryos? King asked, surprised. Oh, I'm not interested in embryos anymore, Dodgson said. Years ago, I tried to get frozen embryos, but there's no reason to bother with embryos now. I want fertilized eggs. And in 4 hours, I'll have them from every species on this island. How can you do that in 4 hours? Because I already know the precise location of every dinosaur breeding site on the island. The map, Howard. King opened the map. It was a large topographical chart of the island, 2 feet by 3 feet, showing terrain and elevation in the blue contours. At several places in lowland valleys, there were dense red concentric circles. In some places, clusters of circles. What's this? King said. Why don't you read what it says? Dodgson said. King turned the map and looked at the legend. Sigma Data Landsat Nordstat Mixed Spectral VSFR Fastlar if VR, and then a bunch of numbers. No, wait. Dates. Correct, Dodgson said. Dates. Past dates? This is a summary chart, combining data from several satellite passes? Correct. King frowned. And it looks like visible spectrum and false aspirated radar and... What? Infrared. Broadband thermal VR, Dodgson smiled. I did all this in about 2 hours. Downloaded all the satellite data, summarized it, and had the answers I wanted. I get it, King said. These red circles are infrared signatures. Yes, Dodgson said. Big animals leave big signatures. I got all the satellite flight paths over this island for the last few years and mapped the location of heat sources, and the locations overlap from pass to pass, which is what makes these red concentric marks, meaning that the animals tend to be located in these particular places. Why? He turned to King. Because these are nesting sites. Yes, they must be, Baselton said. Maybe that's where they eat, King said. Dodgson shook his head irritably. Obviously, those circles can't be feeding sites. Why not? Because these animals average 20 tons apiece, that's why. You get a herd of 20-ton dinos, and you're talking a combined biomass of more than 500,000 pounds moving through the forest. That many big animals are going to eat a lot of plant matter in the course of the day. And the only way they could do that is by moving, right? I guess. You guessed? Look around you, Howard. Do you see any denuded sectors of forest? No, you don't. They eat a few leaves from the trees and move on. Trust me, these animals have to move to eat. But what they don't move is their nesting sites. So these red circles must be their nesting sites. He glanced at the map. And unless I'm wrong, the first of the nests is just over this rise, and down the hill on the other side.
Richard Levine stood on the hide, staring at the herd through binoculars. Malcolm had gone back to the trailer with the others, leaving Levine alone. In fact, Levine was relieved to have him gone. Levine was quite constant to make observation on these extraordinary animals, and he was aware that Malcolm did not share his boundless enthusiasm. Indeed, Malcolm always seems to have another consideration on his mind, and Malcolm was notably impatient with the act of observation. He wanted to analyze the data, but he did not want to collect it. Of course, among scientists, That represents a well-known difference in personality. Physics was a perfect example. The experimentalists and the theorists lived in utterly different worlds, passing papers back and forth, but sharing little else in common. It was almost as if they were different disciplines. And for Levine and Malcolm, the difference in their approach had surfaced earlier. Back in the Santa Fe days, both men were interested in extinction, but Malcolm approached the subject broadly, from a purely mathematical standpoint. His detachment, his inexorable formulas, had fascinated Levine, and the two men began an informal exchange over frequent lunches. Levine taught Malcolm paleontology. Malcolm taught Levine non-linear mathematics. They began to draw attentive conclusions which both found exciting, but they also began to disagree. Then they would go out into the heat of Guadalajara Street and walk back towards the river, still shouting at each other, while approaching Torres hurried to the other side of the street. In the end, their difference came down to personalities. Malcolm considered Levine demetic and fuzzy, preoccupied with petty details. Levine never saw the big picture. He never looked at the consequences of his actions. For his own part, Levine did not hesitate to call Malcolm imperiously and detached indifference to details. God is in the details, Levine once reminded him. Maybe your God, not mine. Mine is in the process. Levine thought that answer was exactly what you would expect from a mathematician. Levine was quite satisfied that details were everything, at least on biology, and that the most common failing of his biological colleagues was influence attention to details. For himself, Levine lived for the details, and he could not even let them go. Like the animal that had attacked him with Diego, Levine thought of it often, turning it over and over again, reliving the event. Because there was something troubling, some impression that he could not get right. The animal had attacked quickly, and he had sensed it was basically theropod form. Hind legs, stiff tail, large skull, the usual. But in a brief flash in which he had seen the creature, which made him think of Carnotaurus sastre from the Groa Frigo formation in Argentina. And in addition, the skin was extremely unusual. It seems to be sort of bright molded green, but there was something about it. He shrugged. The troubling idea hung in the back of his mind, but he couldn't get to it. He just couldn't get it. Reluctantly, Levine turned his attention to the Parasaurs herd, browsing by the river, alongside the Apatosaurs. He listens as the Parasaurs made their distant, low trembling sounds. Levine noted that most often the Parasaur made a sound of short duration, a kind of rumbling honk. Sometimes, several animals made this sound at once, so it seems to be an audible way to indicate to the herd where the numbers were. Then there was a much longer, more dramatic trumpeting call. This sound was made infrequently and only by two largest animals in the herd, which raised their heads and trumpeted loud and long. But what did that sound mean? Standing there in the hot sun, Levine decided to perform a little experiment. He cupped his hands around his mouth and imitated the Parasaur's trumpeting cry. Levine was pleased by this response and made an entry on his notebook, but when he looked up again, he was surprised to see that the Parasaur herd was drifting away from the Apatosaurs. They collected together, forming a single line, and began to walk directly towards the hide. Levine started to sweat. In some bizarre corner of his mind, he wondered if he had imitated a mating call. That was all he needed to attract a randy dinosaur. Who knew how these animals behave in mating? With growing anxiety, he watched them march forward. Probably he should call Malcolm and ask his advice. But as he thought about it, he realized that by intimidating that call, he had interfered with the environment, introducing a new variable. He had done exactly what he had told Thorne he did not intend to do. It was thoughtless, of course, and surely not important in the scheme of things, but Malcolm was certainly to give him hell about it. Levine lowered his binoculars and stared. A deep trumpeting sound reverberated through the air, so loud it hurt his ears. The ground began to shake, making the hide swung back and forth precautiously. My God, he thought, they're coming right for me. He bent over and with fumbling fingers searched for his backpack for the radio. In the trailer, Thorne took out a rehydrated meals out of the microwave and passed the plate around the little table. Everyone unwrapped them and began to eat. Malcolm poked his fork into the food. What is this stuff? Her baked chicken breast, Thorne said. Malcolm took a bite and shook his head. Isn't technology wonderful? They managed to make it taste just like cardboard. Malcolm looked at the two kids seated opposite him, who were eating energetically. Kelly glanced up at him and gestured with her fork at the book strapped into the shelf beside the table.
One thing I don't understand.
Only one? Malcolm said.
All this business about evolution. Darwin wrote this book a long time ago, right?
Darwin published The Origin of Species in 1859, Malcolm said.
And by now, everybody believes it. Isn't that right?
I think it's fair to say that every scientist in the world agrees that evolution is a feature of life on Earth, Malcolm said, and that we are descended from animals' ancestors. Yes.
Okay, so what's the big deal now?
Malcolm smiled. The big deal is that everybody agrees evolution occurs, but nobody understands how it works. There are big problems with the theory, and more scientists are admitting it. Malcolm pushed his plate away. You have to track the theory, he said, over a couple of 100 years. Start with Baron Georges Cuvier, the most famous anatomist in the world in his day, living in the intellectual center of the world, Paris. Around 1800, people began digging up old bones, and Cuvier realized that they belonged to animals no longer found on Earth. That was a problem, because back in 1800s, everybody believed that all the animal species, even created, were still alive. The idea seemed reasonable because the Earth was thought to be only a few thousand years old, and because God, who had created all the animals, who never let any of his creations become extinct. So extinction was agreed to be impossible. Cuvier agonized over these dug-up bones, but he finally concluded that God or no God, many animals had become extinct. As a result, he thought, a worldwide catastrophe like Noah's flood.
Okay.
So Cuvier reluctantly came to believe in extinction, Malcolm said, but he never accepted evolution. In Cuvier's mind, evolution didn't occur. Some animals died and some survived, but none evolved. In his view, animals didn't change. Then along came Darwin, who said that animals did evolve, and that the dug-up bones were actually the extinct predecessors of living animals. The implication of Darwin's idea upset lots of people. They didn't like to think of God's creation changing, and they didn't like to think of monkeys in their family trees. It was embarrassing and offensive. The debate was fierce, but Darwin amassed a tremendous amount of factual data. He had made an overwhelming case. So gradually, his idea of evolution was accepted by scientists and by the world at large. But the question remained, how does evolution happen? For that, Darwin didn't have a good answer. Natural selection, Arby said. Yes, that was Darwin's explanation. The environment exerted pressure which favors certain animals, and they breed more often in subsequent generations, and that's how evolution occurs. But as many people realize, natural selection isn't really an explanation. It's just a definition. If an animal succeeds, it must have been selected for. But when an animal is favored? And how does natural selection actually operate? Darwin had no idea. And neither did anyone else for another 15 years.
But it's genes.
Okay, Malcolm said. Fine. We came to the 20th century. Mendel's work with plants is rediscovered. Fisher and Wrench do population studies. Pretty soon we know genes control heredity, whatever genes are. Remember, through the first half of the century, all during World War I and World War II, nobody had any idea what a gene was. After Watson and Crick in 1953, we knew that genes were nucleotides arranged in a double helix. Great. And we knew about mutation. So by the late 20th century, we have a theory of natural selection which says that mutation arose spontaneously in genes, that the environment favors the mutations that are beneficial, and out of this selection process of evolution occurs. It's simple and straightforward. God is not at work. No higher organizing principles involved.
In the end, evolution is just a reason of a bunch of mutations that either survive or die. Right? Right, Arby said. But there are problems with that idea, Malcolm said. First of all, there's a time problem. A singular bacterium, the earliest form of life, has 2,000 enzymes. Scientists have estimated how long it would take to randomly assemble those enzymes from a primordial soup. Estimates run from 40 billion years to 100 billion years, but the Earth is only 4 billion years old. So, chance alone seems too slow, particularly since we know bacteria actually appeared only 400 million years after the Earth began. Life appeared very fast, which is why some scientists have decided life on Earth must be extraterrestrial origin, although I think that's just evading the issue. Okay. Second, there's the coordination problem. If you believe the current theory, then all the wonderful complex of life is nothing but the accumulation of change events. A bunch of genetic accidents strung together. Yet when we look closely at the animals, it appears as if many elements must have evolved simultaneously. Take bats, which have echolocation. They navigate by sound. To do that, many things must evolve. Bats need specialized apparatus to make sounds. They need specialized ears to hear echoes. They need specialized brains to interpret the sounds. And they needed specialized bodies to drive and swim and catch insects. If all these things don't evolve simultaneously, there's no advantage. And to imagine all these things happen purely by change is like imagining that a tornado can hit a junkyard and assemble the parts into a working 747 airplane. It's very hard to believe. Okay, Thor said, I agree. Next problem. Evolution doesn't always act like a blind force should. Certain environmental niches don't get filled. Certain plants don't get eaten. And certain animals don't evolve much. Sharks haven't changed for 165 million years. Opossums haven't changed since dinosaurs became extinct 65 million years ago. The environments for these animals have changed dramatically, but the animals have remained almost the same. Not exactly the same, but almost. In other words, it appears they haven't responded to their environment. Maybe they're still well adapted, Arby said. Maybe. Or maybe there's something else going on that we don't understand.
Like what?
Like other rules that influence the outcome. Are you saying evolution is directed? No, Malcolm said. That's creationism, and it's wrong. Just plain wrong. But I'm saying that natural selection acting on genes is probably not the whole story. It's too simple. Other forces are also at work. The hemoglobin molecules is a protein that is folded like a sandwich around a center iron atom that binds oxygen. Hemoglobin expands and contracts when it takes on and gives up oxygen, like a tiny molecule lung. Now, we know the sequence of amino acids that make up hemoglobin, but we don't know how to fold it. Fortunately, we don't need to know that, because if you make the molecule, it folds all by itself. It organizes itself. And it turns out, again and again, that living things seems to have a self-organizing quality. Proteins fold. Enzymes interact. Cells arrange themselves to form organs. And the organs arrange themselves to form a coherent individual. Individuals organize themselves to make a population. And population organize themselves to make a coherent biosphere. From complexity theory, we're starting to have a sense of how this self-organization may happen and what it means, and it implies a major change in how we view evolution. But in the end, evolution still must be the result of the environment acting on genes. I don't think it's enough, Arp, Malcolm said. I think more is involved. I think there has to be more, even to explain how our own species arose. About 3 million years ago, Malcolm said, some African apes that had been living in the trees came down to the ground. There was nothing special about these apes. Their brains were small, and they weren't especially smart. They didn't have claws or sharp teeth for weapons. They weren't particularly strong or fast. They were certainly no match for the leopard. But because they were short, they started standing upright on their hind legs to see over the tall African grass. That's how it began. Just some ordinary apes, looking out over the grass. As time went on, the apes stood upright more and more at the time. That left their hands free to do things. Like all apes, they were tool users. Chimps, for example, used twigs to fish for termites. That sort of thing. As time went on, our ape ancestors developed more complex tools. That stimulates their brains to grow in size and complexity. It began a spiral. More complex tools provoke more complex brain, which provokes more complex tools. And our brains literally explode. In evolutionary terms, our brains more than double in size is about 1 million years. And that caused problems for us.
Like what?
Like getting born, for one thing. Big brains can't pass through the birth canal, which means both mother and child died in childbirth. That's no good. What's the evolutionary response? To make human infant born very early in development, when their brains are still small enough to pass through the pelvis. It's the marsupial solution. Most of growth occurs outside the mother's body. A human child's brain doubled during the first year of life. That's a good solution to the problems of birth, but it creates other problems. It means that human children will be helpless long after birth. The infants of many mammals can walk minutes after they're born. Others walk in a few days or weeks, but human infants can't walk for a full year. They can't feed themselves for even longer. So one prize of big brains was that our ancestors had to evolve new, stable social organization to permit long-term childcare, lasting many years. These big brains, totally helpless children changed society. But that's not the most important consequence.
No?
No. Being born in an immature state means that human infants have unformed brains. They don't arrive in a lot of built-in, instinctive behavior. Instinctively, a newborn infant can suck and grasp, but that's about all. Complex human behavior is not instinctive at all. So human society had to develop education to train the brains of their children, to teach them how to act. Every human society expends tremendous time and energy teaching its children the right way to behave. You look at a simple society, in the rainforest somewhere, and you find that every children is born into a network of adults responsible for helping to raise the child. Not only parents, but aunts and uncles and grandparents and tribe elders. Some teach the child to hunt or gather food or weave. Some teach them about sex or war. But the responsibilities are clearly defined. And if a child does not have, say, a mother's brother's sister to do a specific teaching job, the people get together and appoint a substitute. Because raising children is, in a sense, the reason the society exists in the first place. It's the most important thing that happens, and it's the culmination of all the tools and language and social structures that has evolved. And eventually, a few million years later, we have kids using computers. Now, if this picture makes sense, where does natural selection act? Does it act on the body, enlarging the brain? Does it act on a developmental sequence, pushing the kids out early? Does it act on a social behavior, provoking cooperation and child caring? Or does it act everywhere at once? On bodies, on development, and on social behavior? Everywhere at once, Arby said. I think so, Malcolm said. But there may also be parts of this story that happen automatically, the results of self-organization. For example, infants of all species have a characteristic appearance. Big eyes, big heads, small faces, uncoordinated movements. That's true of kids and puppies and baby birds. And it seems to provoke adults of all species to act tenderly towards them. In a sense, you might say infants' appearance seems to self-organize adults' behavior. And in our case, a good thing too. What does that have to do with dinosaurs' extinction? Self-organizing principles can act for better or worse. Just as self-organization can coordinate change, it can also lead a population to decline and cause it to lose its edge. On this island, my hope is we'll see self-organizing adaptations in the behavior of real dinosaurs. And it'll tell us why they became extinct. In fact, I'm pretty sure we already know why the dinosaurs became extinct. Bravo! I couldn't have put it better myself. But perhaps you better see what is happening out here. The Parasaurs are doing something very interesting, Ian.
What's that?
Come and look.
Kids, you stay here and watch the monitors. Richard, we're on our way. Richard Levine ripped the railing of the hide and watched tensely. Directly ahead, coming into the view over the low rise, he saw the magnificent head of a Parasaurolophus walkery. The duck-billed hadrosaur skull was 3 feet long, but it was made larger by the long-horned crest that extended backward high in the air. As the animal approached, Levine could see the green motley on the head. He saw the long, powerful neck, the heavy body with its light green underbelly. The Parasaurolophus was 12 feet tall, and roughly the size of a large elephant. Its head was almost as high as the floor of the hide. The animal moved steadily towards him, its footsteps thumping on the ground. Moments later, he saw the second head appear over the rise, then a third, and a fourth. The animals trumpeted and walked in single file directly towards him. Within moments, the lead animal was a breeze of the hide. Levine held his breath as it passed. The animal stared at him, its large brown eyes rolling to watch him. It licked its lips with a dark purple tongue. The hide shook its footsteps, and then it passed, continuing on towards the jungle behind. Soon after, the second animal passed. The third animal brushed against the structure, rocking it slightly. But the dinosaur did not seem to notice. It continued steadily on. So did the others. One by one, they disappeared into the dense foliage behind the hide. The earth ceased to vibrate. It was then he saw the game trail running past the hide and into the jungle. Levine sighed. His body relaxed slowly. He picked up his binoculars and took a deep breath, calming himself. His panic faded. He began to feel better. Then he thought of where they were going, because as he considered it, the behavior of the Parasaurs seemed extremely strange. They had been in a defensive cluster while they fed, but in movement they had shifted to single file, which broke the usual cluster herd patterns and made every animal vulnerable to predation. Yet the behavior was clearly organized. Moving in single file must serve some purpose. But what? Now that they were within the jungle, the animals had begun making low trumpeting sound of short duration. Again, he had the sense that this was some sort of vocalization to convey position, perhaps for members to keep track on each other while they moved through the jungle, while they changed locations. But why would they change locations? Where were they going? What were they doing? He certainly couldn't tell here, standing up in the hide. He hesitated, listening to them. Then, in a decisive moment, he swung his legs over the railing and climbed quickly down the scaffolding. She felt heat and wet. Something rough scrambled along her face like a sandpaper. It happened again, this roughness on her cheek. Sarah Harding coughed. Something dripped on her neck. She smelled an odd sweaty odor like fermenting African beer. There was a deep hissing sound. Then the rust scrambled again, starting at her neck, moving up her cheek. Slowly, she opened her eyes and stared at the face of a horse. The big, dull eyes of the horse peered down at her with soft eyelashes. The horse was licking her with its tongue. It was almost pleasant, she thought, almost reassuring, lying on her back in the mud with the horse. It wasn't a horse. The head was too narrow. She suddenly saw the snout too tapered, the proportions all wrong. She turned to look and saw that it was a small head leaning to a surprisingly thick neck and a heavy body.
Oh my God!
Her sudden movement startled the big animal, which snorted and alerted, and moved slowly away. It walked a few steps down in the muddy shore, and then turned back, looking at her reproachfully. But she could see it now. Small head, thick neck, huge lumbering body,
and a double rows of pentagonal plates running along the crest of the back. A dragging tail with spikes on it. Harding blinked. It couldn't be. Confused and dazed, her brain fumbled for the name of the creature, and it came back to her all the way from childhood. In her astonishment, her mind went back to the glance of the white hospital room where she had visited Ian Malcolm in his delirium when he mumbled the names of various dinosaurs. She had always had her suspicions, but even now, confronted by a living stegosaur. Sarah squinted at the animal, looking for a seam in the costume, mechanical joints beneath the skin. But the skin was seamless, and the animal moved in an integrated organic way. The eyes blinked again slowly. Then the stegosaur turned away from her, moved to the water's edge, and lapped it with its large, rough tongue. The tongue was dark blue. How could that be? Dark blue with Venian's blood? Was it cold-blooded? No. This creature didn't behave that way at all. It stood in its shape and lapped up the cold water, indifferent to it at all. She looked down her shirt, was foamy splitted running down from her neck. It had drooled on her. She touched it with her fingers. It was a warm bladder, all right. The stegosaurus' skin has pale texture, but it was not scaly like reptiles. It was more like the skin of a rhino, she thought, or a warhog. The stegosaurus moved slowly. It had a peaceful, rather than stupid air, and it probably was stupid, she thought. Looking again at the head, the brain case was much smaller than that of the horse, very small for the body weight. She got to her feet and going. Her body ached. Every limb and muscle was sore. Her legs trembled. She took a breath. A few yards away, the stegosaurus paused, glaring at her, taking her new upright appearance. When she did not move, it began indifference over again and returned to drinking from the river. She looked at her watch. It was 1:30 in the afternoon, the sun still high overhead. She couldn't use the sun to navigate, and the afternoon was very hot. She decided it had better start walking and trying to find Malcolm and Thorn, barefooted, moving stiffly, her muscles itching. She headed into the jungle, away from the river. After walking half an hour, she was very thirsty, but she had trained herself to go without water for long periods in the African savanna. As she approached the top of the ridge, she came to a game trail, a wide muddy track through the jungle. It was easier to walk along the trail, and she had been following it for about 15 minutes when she heard an excited yelping from somewhere ahead. It reminded her of dogs, and she proceeded with caution. Moments later, there was a crashing sound on the underbrush, coming from several directions at once, and suddenly a dark green lizard-like animal about 4 feet high burst through the foliage in a terrific speed, screeching and leaped over her. She ducked instinctively, and hardly had time to recover before a second animal appeared and raced past her. With instinct, the whole herd of animals were running past her on all sides, yelping in fear, and then the next one brushed against her, knocking her over. She fell in the mud as the other animals leaped and crashed around her. A few feet ahead onto the trail, she saw a large tree with low-hanging branches. She acted without thinking, jumped to her feet, and grabbed the branch and swinging up. She reached safety just as the new dinosaur with a sharp claw feet rushed through the mud beneath her and chased after the fleeing green creatures. As this animal went away from her, she glimpsed a dark body 6 foot tall with reddish stripes like a tiger. Soon after, a second striped animal appeared, then a third. A pack of predators hissing and snarling as they pursued the green dinosaurs. For her years in the field, she found herself automatically counting the animals that rushed past her. By her count, there were 10 striped tigers, and that immediately triggered her interest. As soon as the last of the predators were gone, she dropped down to the ground and hurried to follow them. It was occurred to her that it might be foolish to do so, but her curiosity overcame her. She chased the tiger dinosaurs up a hill, but even before she reached the crest, she could tell from the snarls and growls that they had already brought an animal down. At the crest, she looked down on their kill. But it was like no kill she had ever seen in Africa. The biggest predators, lions or hyenas, were the closest to the carcass, feeding with their young. Farther out, waiting their turn, were the vultures and marabou storks. And still further out, jackals and other small scavengers circled rearing. After the big predators finished, the small animals moved in. Different animals eat different parts of the body. The hyenas and vultures ate bones, and the jackals nibbled the carcass clean. This was the pattern at any kill, and as the result, there were little scrambling and fightings around the food. But here she saw pandemonium, a feeding frenzy. The fallen animal was strictly covered with striped predators, all furiously ripping the flesh of the carcass, which frequently paused to snarl and fight with each other. Their fights were open vicious. One adult bit an adjusted animal, inflicting a deep flank wound. Immediately, several other predators snapped at the same animal, which limped away, hissing, bleeding, and badly wounded. Once at the prison, the wounded animal retaliated by biting the tail of another creature, again causing serious bleeding. A young juvenile about half the size of the others kept pushing forward, trying to get a piece of the carcass, but the adults did not make room for it. Instead, they snarled and snapped in fury. The youngster was frequently obligated to hop back nimbling, keeping his distance from the razor-sharp fangs of the grown-ups. Harding saw no infants at all. This was a society of vicious adults. As she watched the big predators, their heads and bodies smeared with blood, and she noticed the crisscross patterns of healed scars in their flanks and necks. These are obviously quick, intelligent animals, yet they fought continuously. Animals of many species fought for food, territory, and sex. But these fights most often involved displaying and ritual aggression. Serious injuries seldom occurred. There were exceptions, of course, when male hippos fought to take over harem, when often severely wounded the other males. But in any case, nothing matches what she had saw now. The wounded animal at the edge of the kill slunk forward and bit another adult, which snarls and leapt at it with a slashing with its long toe claw. In the flash, the injured predator was eviscerated, cause of tail and intestines slipping out through the white gash. The animal fell, howling to the ground, and immediately 3 adults turned away from the kill and jumped onto the newly fallen body and began to tear the animal's flesh with rapid intensity. Harding closed her eyes and turned away. This was a different world, and one she did not understand at all. In the days, she headed back down the hill, moving quietly, carefully away from the kill.